So now with the new cap installed, we can then go to the lab calibration. Now this sensor cap has a 6-month life, and the life begins the first time you use it. So if we do a lab calibration, its life will begin. So if you're trying to use the life of the sensor for all deployment time, you may want to do this calibration just before deployment. Now to do the calibration, we need to connect this to the U26 to the computer. So we take off the covering to the optical port and we connect our coupler. Again, the ridge on the coupler aligns with the arrows on and the notch on the U26. The green light saying we have connection, and now we're in a position where we can begin calibration. When we go to calibration, we want to go to the main screen and we click Device and then Lab Calibration. And what we have now is a screen that shows the beginning of the 100% saturation test. And what we're doing now is we're going to create an environment over the sensor that's 100% water saturated air. In order to do that, we have included a boot that contains a sponge that will create that environment. The sponge has to be wetted. So we take the sponge, allow it to get nice and wet, but then we have to squeeze out the excess water because we're really just looking for a damp sponge. We don't want water running all over the inside of the boot because liquid water on the face of the sensor will damage the results. So we have a damp, squeezed out, wet sponge that goes into the end of the boot, and then the boot goes over the sensor end of the logger and then over the main body for about ½ an inch. Makes a nice tight seal around here, and there's a pressure relief port on the bottom, and now the air inside of the boot is becoming 100% saturated. However, it takes 15 minutes to accomplish that task. So we basically have to wait 15 minutes for that environment to become correct. Okay, in order to do the 100% saturated test, the computer also needs to know the barometric pressure. Okay, so on the screen for a 100% saturated test, the first thing we need to enter is the barometric pressure right here in the room. And I have a meter that measures barometric pressure, and it's reading 760 millimeters of mercury. Step 1 is for 100% saturation. We enter the barometric pressure of 760. This is the absolute pressure, so I don't have to adjust it for the sea level. And then we click Get DO Value from Logger. Okay, this first number in blue is the actual reading of the logger, 8.83. The value should be 8.35 when the air is fully saturated in the boot. And this is the gain adjustment parameter to make these be the same. And during the 15-minute wait, you can click it again. You can click this as many times as you like during the wait and watch the values equalize. Now again, after 15 minutes they won't be the same. That's why we're generating a gain adjustment factor. This time it's 8.81. But after 15 minutes, everything should be at equilibrium. 15 minutes has been completed. The last several checks, the new gain adjustment is consistent. At 997. So it looks like a good test. So we'll go to the next step, which is to do 0% saturation by clicking the next button. Okay, so now we're at the 0% saturation, and we now have to generate that environment for the logger. Okay, so we've completed the 100% saturation point. Now we need to generate the environment for 0% saturation for the sensor. So we remove the boot, set it aside, and what we're going to use is now a container to hold a sodium sulfite solution. Sodium sulfite is a solution that has 0% DO saturation. Any oxygen that goes into solution reacts with sodium sulfite and becomes sodium sulfate. So we need to put enough solution into this container so that when the lager goes in, the level will go up to along the side of the lager. And you may want to practice this with water first to get that level right, because you don't want water squirting out the top and you don't want it to be too low. So you may want to experiment. I did with this container, and I marked it, the level that I wanted to pour the sodium sulfite into the container with. Here is my sodium sulfite. I pour it up to the level that I know will be just the right amount. Then I insert the sensor end of the lager in, and notice that when it's in, the level of the liquid is up along the side of the lager, so the sensor itself is fully submerged. And then also I want to make sure that no air bubbles are entrapped on the surface of the DO detecting surface, because it is a flat surface facing down. A bubble could adhere, so I just shake it a bit, make sure that there are no bubbles, and I can actually see that there's no bubbles on the surface of the sensor. So now my lager is in a 0% saturated condition. However, it takes time for the sensor and that solution to go to equilibrium. We need to wait long enough so that the reading we're getting from the lager is no longer changing. So we'll wait additional time, or the full 15 minutes. And now we're at 15 minutes, we'll do one more check. Okay, still minus 0.01, it's at 15 minutes, so that will complete this step. And now we'll go to the final step. And we click the next button. This now gives us the results of our calibration. We now have a new gain coefficient of 0.995 as a result of our measurement from the lager and the calculated value that it should be from the barometric pressure calculation. We also have the offset of minus 0.01 from the 0% saturation part of our calibration, and these are the results. Now at this point we can look at these numbers and decide whether we think they're valid or not. That is, if one number is excessively larger than one, or our offset is quite large, we could choose to not enter these values and simply go back or close. But if we think these are good values, and I believe they are, we simply check Send Calibration to Logger. Then these new coefficients will be sent to the logger's memory. Okay, it's been sent. They are duly noted up here where we were keeping track of the gain and offset in the logger. It has also updated the calibration date and time to being right now. And we can now close out this operation.